We're going to learn how to make an ipart by going back to the single cylinder engine and knowing that this is one entire valve block. This is the intake block. It has, this is the middle block. It has through holes. This is the intake block and it has countersink holes that the screw would sit in, and it says the exhaust valve block is identical except the 4 holes that are tapped are 256 through. So we're going to make an ipart of this part, and the exhaust part. So the middle, intake, which are these 3 views, and the exhaust. Now this is just a match drill hole for when the valve guide is pressed into the block. So we're not going to make this hole. We're going to make the pilot hole first, and then when the assembly is made, then we'll come back and make this one. The first thing we want to do is understand the assembly. So we have a port for the intake and one for the exhaust, and this port goes to the head. So essentially through these 2 screws, this whole assembly gets attached to the head of the single cylinder engine. When we go to that, that would be right here. So there's a port that goes through to the head, and as the pistons pull back, it allows the gas and oil mixture to come in here. And then as compression comes forward, we do get that dwell, that compression, and then the spark from the spark plug fires, and then we get the power from that. From the valve block, what we have are springs on the top and bottom. So this is a subassembly. This valve guide would be press fit into this valve block, the intake, as well as the exhaust block down here. Then the springs would be put on, the keepers would be put on top, and then a pin put through here to secure the pressure against the spring so that the keeper stays on and the spring stays in. So what we're going to do now is we're going to look at one part, and we're going to make all 3 of these by allowing and suppressing features. And in doing that, we can also make an eye assembly that has parts in it and then doesn't have parts in it, so we're making configurations. So what I have here is a normal block. I started with a body, and I named my features because it's going to be easier than just extrusions or holes. So you want to name your features as you go through this because you're going to be using a spreadsheet type situation. Now one thing that we notice in the input is that the holes that attach all these 3 parts are in exactly the same location. So those 3 holes, those 4 holes right there, plus the pass-through hole in the middle can be created with one sketch. So the way that I did that was I shared the sketch. So what we have now is the body, and I have all these points in the first sketch from the body. So they're dimensioned and they're aligned. So if I go to this sketch, you can see that it's been moved outside the body because it's used in more than one feature. So the next feature that I created was this these through holes. So these are the matching holes. They're the through holes that go all the way through the valve on the left. They're just simple through holes for the screws. On the intake we'll have countersink holes for the heads, and on the exhaust we'll have threaded holes. But still, I have these holes. So I've got that done. The next thing that I need to do for that first piece, which is on the left, is put this middle pass-through hole. So as the valves are moving up and down, they're compressing and exhausting air, and this has to pass through so that they can all exhaust and compress the way that they should. The mounting assembly holes are right here, which are only in the middle block. That mounts the assembly to the head, and then this hole is also just in the middle block because it allows that gas or exhaust to come either in or out of the head and come up into the next block and either come in from the carburetor or go out through the exhaust. So now I have my first piece made, and the way that we actually share this sketch is you can right click and just make it visible, and then you can use the features again. So that's a way that I had the points show up to make my matching holes right here, and then also to make my hole through the middle pass. The next thing that we're going to do is we're going to create this as an ipart. So we're going to manage this part and create an ipart from it. So what it does is it goes through and it shows you all the different dimensions that you could actually use and the different features that you could use. So we want to go through a suppression project. We're going to add or suppress. We could change threads, we can change work features, we can change the properties or the parameters, which are the actual dimensions in the part. We could also change other things such as materials. So you see that I have I valve block here, and that's what I'm starting with, and the part number might be middle. And so for the part middle, which is the first one that I did, I need the body and all these other features. So I had just, if you double click on it, it puts it in the other one. So you can see that in the middle part, all these are computed. We're going to suppress some of these features in the next parts. So now I'm going to right click here and insert a row. When I do that, I have I valve block again, and this one I'm going to call the intake. So we might call this middle, because I think when it highlights in yellow that it's saying that those are both the same member. So in the intake, we're also going to compute the body. It's going to be the same. The matching holes are not going to be through holes, so we're going to suppress them with an S. And for the middle pass hole, we're going to allow it or suppress it. That's a countersink hole, so I'm going to suppress this one. It's a different kind of hole. And then I'm going to go to mounting assembly. We don't need those because we're only mounting through the middle block. And we don't need this one through to head. So I'm going to say verify right here. It's going to make sure that everything's okay. And then the next thing that I'm going to go ahead and do, I'm going to insert another row. And I'm going to say that this is going to be the exhaust. Now in the exhaust, we're going to compute the body again. We're going to suppress the matching. We're going to suppress all these things, but we're going to add some more things to this. So I'm going to go ahead and verify this. Say OK. And accept. So what you're going to see right here from the table is that it has created these three parts from that table. So right now we're in the middle block. If I double click on the intake now, the intake has nothing in it. If I go back to the middle block, it has all those features that we computed. Neither the intake or the exhaust would have those. But notice that I still have my sketch here to use. So the next thing that I'm going to do is I'm going to go to these views on the right here, and I'm going to make the intake, and then all I have to do is change the countersink holes to 256 threaded holes, and then I'm done. So first thing I'm going to do is I'm going to create another hole. I'm going to use these points, and if it selects all the points from you, the way that you deselect is you hold down Control and you select a point again. So it's gathering or suppressing holes. This is a countersink hole, and the call out for those holes is 089, and we said that the top is 172 at 82 degrees, and say OK or apply, because I need another hole in here. Now this hole is supposed to be on the intake. The countersink is on the bottom, so I'm going to create a sketch on this one, and I'm going to project the geometry of that center hole, that center point, through that part onto that other surface. Say OK. So I'm essentially taking it from one plane to the next, and now I can say I want to make a hole with this point. I'm going to make it a countersink, not a spot face. The countersink is going to be 375 diameter. It's going to be 31 thousandths deep, and the bore is going to be a 313 through hole. And I'm going to say OK. So I have those features, and so now I'm going to I'm going to name these. I'm going to say these are going to be intake matching. I'm going to have the next hole, which is the valve. This is for the valve countersink. I'm sorry, counterbore. And now we've got one more. So we're going to go over onto the side and we're going to create a sketch. And from this we're going to put a hole, or we could just finish this and we could say that we're going to just put a hole in the side. Now I don't really need a sketch to do that if it goes from two edges. So I could use a hole from sketch that's concentric to another one, or a linear hole. And that one wants to know what face to drill on. It wants to know what kind of hole, of course. It needs to know the two references to dimension from. So I'm going to dimension from this edge over here, 0.313, and from this edge over here, 0.125. Don't hit enter or it'll complete. And then that hole is blind. It's 0.219, and it is not through wall. It's in a distance of 0.188 because it's only a pilot hole to go in so that you can match drill later. Alright, now that I have those, I'm going to call this intake exhaust, because the intake port's going to come in through there, and that's the exhaust port for the exhaust pipe. So I'll call it that. Now I have some more features. So in this, I can right click and I can say edit the table. And you can edit it via a spreadsheet. But if you go to suppression, you notice that we have a lot more features here. So in these, in the valve block intake, we're going to add these to it. Valve counterbore and the intake exhaust port. Now in these, we don't need these in here. This was already finished, so we're just going to put an S in there for suppress. And we're going to compute those, but I don't need the intake matching holes. Those are countersink, so I'm going to suppress these in the exhaust. I still need the valve counterbore, and I need the exhaust port. Okay, so I'm going to verify, say OK. And now when I look at my valve block intake, I've got the countersink holes, the counterbore on the bottom, and the intake or exhaust port. If I go back to iValve block middle, it doesn't have any of those. Now I'm going to go to iValve block exhaust. So what I did, remember, was I suppressed those countersink holes because I need 256 holes through there. So I'm going to make another kind of hole on these same centers, and we're going to make this a threaded hole. And it says that it can't find that for me, so I don't know why, but let's see if I trick it. Okay, so it can't find my data. So these four holes are going to be simple holes. They're going to be threaded holes, and they're going to be 256 all the way through. So if I just made those, let's just say that I'm going to bolt them together. Let's say that I make these clearance holes, simple holes that are, these other ones started out, let's say we make these 089 as well, and they go through all. And if I had a way to create these with threads right now, I would have done that instead of doing what I'm doing right now. But if you look at this, I would call this exhaust matching. So what we have now is we're going to go back and edit the table, and none of those features have been added. So if I go to suppression again, I'm going to add exhaust matching to the setup, and I'm not going to have it in the middle. I'm not going to have it in the intake, but I'm going to have it in the exhaust. And so what happens whenever you don't suppress one of these holes that are right on top of each other, you're going to get an error that it did not change the face of the part because you got a hole inside a hole. So you have to make sure that you do these one configuration at a time. I'm going to say verify and say OK. So as I go through this now, I have the middle block, I have the intake block, and I have the exhaust block. And as these are these are through holes or threaded holes. I can flip it upside down or spin this around and I can still use the same block in the assembly.